My question is about food, okay? You didn't touch alcohol and specific wine. So I want to know your perception about that.
I didn't mention alcohol. You're right, I should have. I just didn't mention it. Alcohol is one of those things. We'll put that right there with the nicotine and the sugar and the rest of it. It clouds the mind, and it's something you can do without. Okay. Now, that doesn't mean that in an evening at dinner, before you're just going to eat dinner and then you're going to have a little talk or something and you're going to go to bed. Well, you probably don't have to be real clear-minded to go to bed or those kinds of things. And if you had a little alcohol then, it's probably not a problem. But if you drink alcohol before you come here in the morning or at lunch and then you come back here, then your mind is cloudy and you're not going to understand as much. So, yes, alcohol belongs in the same list of other psychotropic substances that get in the way of a clear mind. And I say this because if you begin living your life with a clear mind, you'll live a different life than what you're living now. It'll be different. You see, when I sit here and I'm talking with you, like I said before, I'm really connected to other places at the same time. I'm downloading information. You ask me a question, I try to get information about you and your question. What's behind the question? What is it I need to tell you that will actually solve your problem? And that's all going on in the background. I can't do that without a clear mind. If my mind's foggy, then my perception's foggy. And it's the same with you. We're all netted. All of us communicate with each other all the time. We're all netted. But we're foggy. We don't see it. We don't get it. The communications are subtle, and a little bit of fog blocks them out. You see, a lot of this communication, a lot of the interaction in the larger conscious system is subtle, and you have to interpret. And if you don't have a clear mind, you just miss it. So we will understand each other better. When you and another person are having a conversation, you'll not only get the words, but you'll get all the stuff behind the words. You'll read between the lines because you'll be picking up a lot of nonverbal cues, and I don't mean body language, but nonverbal cues, consciousness to consciousness. You'll understand all sorts of things better. You understand your children better, your parents better, Relationships will start to clarify because you are awake completely. You're getting a lot more data. So that's the problem. When you live in a fog, I know you don't feel the fog because the fog's normal. But when you stop living in the fog, you don't want the fog to come back. Like the fog's a problem. So then avoiding the alcohol, the tobacco, the caffeine, the sugar becomes easier and easier because your addictions get less and less, and you wouldn't cloud your mind on purpose for anything because it dulls you. So that's the thing. Yes, alcohol goes right in that. So, and another thing I should say about the food too is don't be a fanatic about anything. Okay? Don't be a fanatic. If you say, okay, I don't eat meat, and you go to somebody who's invited you to dinner and they're serving something that has meat in it, I can't eat that, it has meat in it. That's not good. You need to be a part of a larger thing. You need to be polite. People are trying to please you by serving you this really nice meat, you see. Don't be rude. Like we said, a little bit isn't a problem. In that case, you didn't cause that animal to be killed, through the cycle. You're like a vulture, you're just there and it's opportunity. So the moral issue isn't there. If you want to have a glass of beer or a glass of wine or something sometime, and it's a good time when you really don't have to be that focused, you just want to mellow out or something, that's okay. Don't be fanatic about anything. Understand these things. Understand how they affect you. You will want to be clear. You won't want this other stuff. You'll get to the point, if you eat something with sugar in it, you feel bad. The world gets fuzzy and you get a headache. So you won't want to do that. But if it happens, particularly when you're traveling, traveling, you can't control your environment very much when when you're traveling. You can't necessarily eat the things and drink the things that you want to when you're traveling. So what does that mean? Stop traveling? No, you just make do the best you can with what you've got and go on. You see, it's not the details that matter. You don't have to be an absolutist and a fanatic about any of this. You can break all the rules some of the time. You just can't break the rules all of the time. Then it will make you ill and it will confuse your mind. So that's important, that we understand that we still need to be polite, and we don't look down at other people for doing things that we know are bad for us. And we don't try to convince everybody else to do what we do. You really should become a vegetarian. That's not helpful either. You can talk about it. It's not that you have to keep it to yourself. You can share that and say, look, I'm a vegetarian and I feel good, and I've lost weight, I feel better. That's fine, but don't impose your ideas on anybody. Just share them and let them go. Don't feel like you can never make a mistake, can never do things out of the ordinary. I don't, when I'm at home, I don't eat any animal products. I live on green smoothies, vegetables and fruit, organic vegetables, organic fruit, ground up together in a blender. I live on that. I live on beans, legumes, nuts, seeds, and fruit. That's what I eat. That's what I live on. I don't eat a whole lot of things out of that class. Now, since I've been here, I've probably eaten more eggs, animal protein, than I had for the past 2 years. But that's all right. It's just here because you can't just eat beans, refried beans for every meal. It's not possible. So I want to try the local cuisine. I want to know what real Mexican food is like, right? So I want to sample things. So go ahead and do that. I've done that, and that's fine. That's a good thing. Become part of the culture. So I've had cactus soup and ant eggs and more animal protein, but I wouldn't pass up an opportunity to eat some ant eggs. I'll never get that opportunity unless I come back here, see? And other strange things that I've never had before, but I wouldn't pass up that opportunity to experience that. And that's what I mean by don't be too focused on these things. There's times to let it go and there's times to, my life, 80% of my life, green smoothies, beans, fruit, nuts and seeds. But if I go places where that's just not practical or not fun, I can do different things for a little while. I do turn down the wine, I do turn that because I have to come back here and talk, and I need to be clear. So I avoid the sugar. If I think it has sugar in it, I won't eat it, whether it's something special Mexican delight or not, because it's like disabling me in a way. Okay. So you can be open. Okay. Oh, yes. Turn it on.
How does your theory explain the expansion of the universe?
Thank you, whoever asked that. That's a good question. I'd like to answer. Well, first let's define the problem. The problem is that with our normal traditional physics, we think that the universe and how the planets and all the stars and everything move around mainly has to do with gravity. Okay. Now, the universe isn't exactly a sphere. it's more, we best think now it's more like a toroid, but still, that means you've got all this mass here. And what does mass do? It attracts, right? It comes together. That's why, you know, the moon circles the earth, because there's an attraction between the two. That's why we circle the sun, there's attraction. That's why the whole galaxy, that's why the big galactic pinwheels turn, because that's what gravity says they will do. So if you've got this gravity and all the mass is attracting each other, we expect to look out at the universe and find that it's coming together, or if it's been this big bang and it gets exploded out, that it's slowing down. It's going out slower and slower and slower, then it'll stop and then it'll start coming back together, you know, and this sort of thing. It's what we expect. That's not what we find. What we find is that the universe is not only not slowing down, it's accelerating. So we have all the mass in here in the middle, and out on the edge, it's not slowing down or coming together, it's actually going away faster. Well, what's up with that, right? It just violates what we know about physics. So what physicists do when they have that problem is they say, well, here's our physics, and this doesn't fit our physics. So the equations don't balance here. So what we'll do is we'll just make up something to stick in that equation so that it balances now, so that it works. So what they did is they made up dark energy. Dark energy is this mysterious thing that works the opposite of gravity, that pushes apart, and there's lots of dark energy in the universe, and that's why it's expanding. They just made that up, okay, because in their mind, the equations, our sense of how it works, gravitation and so on, can't be wrong. Okay, so we start with a belief that they can't be wrong, then we make stuff up to make them right. Science has been doing that forever. They don't want you to know they work that way, but they've been doing that forever. Back in the I don't know, 1700s, cosmology was explained by the angels pushed the heavenly bodies around the sun. The sun was pushed by an angel around the earth, actually. Everything out there that moved, the sun, the stars, the moon, all were being pushed by angels. Why? Because the facts were, the stuff seemed to move, right? And it went around, and there was no other explanation, so they just made it up. It was pushed by angels. We think we're above that now, but we're doing the same thing. We do science the same way it was done then. Anyway, that's dark energy. Now, why would a universe expand? And how could it do that? See, the problem is if you think this physical reality is all the reality there is, right? This is it. Physical reality, physical universe, that's reality, nothing else exists. Oh, well, it's expanding. What's it expanding into? What was there before this universe expanded into it if nothing else exists? Where does all this extra space come from? Now that it's a bigger universe, where's it? How do who made the extra space to put in it? How does that work? How do you make space? How is our universe just manufacturing space to get bigger? And what is it moving into? You see all the problems? All these are logical problems. And physicists make up lots of answers, like the angels push all the heavenly bodies around. They say, well, there's dark energy. How about that? Say, all right, that solves the problem. If you understood that it was a virtual reality, you'd understand that the universe can expand indefinitely. It's just a bigger number in the computer. What about the space that the elves walk around in World of Warcraft, or the space that the Sims live in? That's three-dimensional space, right? I mean, they walk from one side of a room to another and have a ceiling above their heads. They live in a 3D space. Where'd that space come from? It's just numbers in a computer. So is ours. It's just numbers in a computer. So in the computer, you can have that universe getting bigger and bigger and accelerating and continuing to get bigger, just because that's the way your algorithms are written in the computer. So it doesn't really take up any more space. You know, if you take your little laptop and you put in a formula for the What, for the size of, put a sphere, equation for a sphere. X squared plus y squared plus z squared equals r squared. That's a sphere. And you can just let r square get bigger, let it double every cycle. Cycle through that in a do loop and let the radius get bigger, double every time you cycle. Well, you wait, computers cycle really fast. You wait for a few seconds, and that sphere that you're calculating will be bigger than our universe. And that's just in a little laptop. How could that be? You've got this great big, well, it's just a calculation. Calculations can expand or do whatever they want. So an expanding universe says, well, that's just the rule set. The way the rule set works, the universe expands, and we just don't understand all the rule set. We understand part of the rule set, maybe the gravitation part, but we don't understand the whole rule set. And other parts of the rule set don't necessarily have to be entirely consistent with the parts that we think we know. Our parts can turn out to be, just a piece of something bigger, and it's not really just like we thought, but it's different than we thought. Not so much that it's inconsistent as it's new and changes. So that's my thought about why the universe is expanding. It's just an artifact of the rule set. It's just the way the virtual reality is computed. And a larger consciousness system that computes this virtual reality can do anything it wants. It can make an expanding universe, or it can make one that stays still, or it can make one that collapses if it likes, I guess. So could we in our simulations. In a digital simulation, almost anything is possible. Yeah. He's talking about the Higgs boson, that you've overstated the case that when you said they've just discovered. That's premature. They have gotten some data that leads them to think that it might be possible that they've seen it. These kinds of things are not as obvious as the press makes them. Okay? They've seen something that looks a little like that, and it could be that, but they won't know for years. That'll still be argued for another 5 years, probably, maybe longer. Okay. So what's going on there? What's going on there in particle physics in general is that we've made up models, and now we're letting the models drive our thinking. Okay, what's called the standard model in particle physics has a hole in it where there's, like the periodic table, right? The way we found new elements in the periodic table was that we saw that there were these organization of things. And that here, the organization had an empty spot. It's like you have the matrix, but there's one square in the matrix that doesn't have anything in it. So now you start looking for the thing that would be in that matrix. Well, that's why they're looking for a Higgs particle. But see, a Higgs particle is not a particle like we think it. This is something that exists for like 10 to the minus 20 seconds. That's all it exists for. And that's not, that's just particle. Then there's the Higgs field. And the Higgs field is supposed to give mass to everything. And you ask them about that, and they say, well, it's like molasses. This Higgs field moves, and as it goes along, it just kind of drags things with it, and it causes inertia. And that's what mass comes from. All of this is just like the angels pushing the heavenly bodies around. You make stuff up to fit the equations and the understanding and the paradigms and the beliefs that you've got. If you say, well, how does that field create mass? Nobody can tell you. It's just that they need something to create mass. They've got no way to explain mass. And they've got this particle that should be there, which is, like I say, a 10 to the minus 22nd existence particle, right? So that particle has to give us mass. Because we need mass, we don't have it, and we've got this one hole left in the chart. So therefore that hole gives us mass. And how do we explain that? And they make up something like the angels pushing the thing around. Oh, it's like a viscous, and that is just nonsense. So you have to take a lot of that with a grain of salt. There may indeed be a tiny little resonance at that spot, that they'll find something that exists there. But that is fundamental or makes any difference. It's just like a little tiny logical, insignificant logical consequence of the rule set, that you get a particle that lasts for 10 to the minus 20 seconds. All the other attributes of it, what it does and how important it is and where it fits in, are models that seem to give explanations, but you can't dig into them too deeply because there's really not much there but smoke. Smoke and mirrors. And science isn't supposed to be like that anymore. We laugh at those scientists back there that had angels pushing the heavens around, but we do the same thing now. It's the way we work. The science people don't like to admit that is touch standard. But Dr. Feynman, Richard Feynman, a very brilliant quantum theorist, he, in a lecture, talks about the angels pushing the heavenly bodies about. And after he explained that that was what the scientists, who were also the priests, thought about it, he asked his students, he says, well, why do we reject that? And a couple of students raised their hands and says, because it's stupid, it doesn't make any sense. And he said, no. Just because it doesn't make any sense is not a good scientific reason to rejecting it. Because you don't know everything. We reject it because it's too complicated. We use Occam's razor that says that if it's a real complicated answer that has a lot of assumptions to prop it up, it's probably not fundamental. And that's still the tool that we should use today in looking at the particle physics. Most of this stuff is extremely complicated with lots of assumptions propping it up, so it probably isn't fundamental. So that's why we reject things, not because we don't understand them or they seem silly to us, because it may be us. That it seems silly to us may be our problem, not their problem. So that's why that I say that it's like string theory is the same way. String theory has like 13 or 14 dimensions in their theory to prop up their theory. And each dimension is an assumption. It's an independent assumption. Well, if you can have enough assumptions, any theory will do anything you want if you can make enough assumptions up. So 14 independent assumptions in string theory tells you that string theory isn't really saying much that's fundamental. Too many assumptions. Same reason that the angels pushing the heavenly bodies around are really not a good idea. Too many assumptions. Where do the angels come from? What do they eat? How do they push those big things around? Just lots and lots of assumptions that have to go into, where do the angels stay at night, or during the day when we can't see the things moving, and on, and it's not a good theory. Neither is really string theory, neither is the Higgs boson as important as it sounds like. Oh, sorry, gave you a little lesson in physics there that probably wasn't appreciated by anybody but the one guy who was asking the question and nodding his head. But anyway, all right. Are we ready for a break?